Okay, the next session, Dan is here. Let me introduce Dan. Hi, Dan.
Hello everyone.
How are you today?
Pretty good. Excited to be here, and
yes,
excited
exactly.
to show everybody what I was thinking about this session.
Me too. Dan will talk about the UI agnostic cross-platform applications. It's an awesome session. Can't wait. Take it over, Dan.
Thank you everyone. Thank you for taking the time to attend this session. My name is Dan and I'm a Microsoft MVP based in Italy. And today I wanted to talk about how you can design your cross-platform native application to be as little as possible dependent on the UI. Of course, the title is a little bit catchy because you cannot design an application without the UI, but we will see how you can architecture to take less dependency on the UI. So the scenario I'm talking about here is I'm a .NET developer, and I would like to develop a native cross-platform application and leverage my knowledge of the .NET. Can I do it? What options do I have? And the really good news is that you don't have one, but at least three options. So you have three UI frameworks that you can use to develop native cross-platform applications. So you have the .NET MAUI developed by Microsoft, which works on iOS, Android, macOS, and Windows. And then you have Uno Platform and Avalonia. Both these frameworks add WebAssembly and Linux support. So now you have three choices, and usually what happens when you have multiple choices, you are afraid to choose one. So which one do I choose? And you start to ask you a lot of questions. My clients ask me those questions. I ask myself those questions. So which framework should I use? What happens if I choose one and the company stops developing the framework? What do I do with my application? How many bugs the framework has? What is the community behind the framework? And the really the good news is that you can actually choose any of them. So all three of them are major frameworks. And actually you can choose any of them. I've been developing mobile with .NET since 2002, since I graduated university. Actually, my first application was a compact framework application running on Pocket PC 2002. And I was lucky enough for 21 years to just use .NET and C#. So the answer is you can use any of those frameworks. And the other question that you should ask yourself, what if the UI framework is not the most important part of your application? So can I design the application to be as independent as possible from the UI framework? So, and the answer is yes, because all these frameworks use the .NET runtime. So now we have this one .NET stack, and all the UI frameworks use that stack. So whatever code we are writing in pure .NET is shareable across all the .NET stack. So I could model as an application actually that I want to implement. It's not the UI. The UI only enables me to interact with the user and to present data to the user. I could model the whole application in a .NET class library. So a pure .NET class library, this actually enables me to share it along the .NET stack. And with this approach, I will be forced to use pure .NET code. So because what actually happens is when you start implementing an application and you use, let's say, the MAUI project, and you start implementing it. At some point, even if you force yourself to a clean architecture, at some point you will be tempted to write code that is not clean, so it's not portable. So with this approach, having everything beside the UI in a .NET assembly, one or more assembly, because I'm looking at this application as a small application. Bigger application, of course, will have multiple assemblies, but everything that it's not UI is in a pure .NET assembly. This also forces me to write only pure .NET code and inject the UI framework functionality using dependencies. So in this case, with this approach, I can use it everywhere. I can easily unit test my application logic, and seeing that all this UI framework use XAML, format XAML, for describing the UI in a shared mode, and all this framework supports that data binding. For the people that do not know what data binding is a mechanism where you connect a property of an UI element with a property of a class inside your code in a business logic, and this communicates automatically. So all this UI framework support data binding. I can easily use the Model-View-ViewModel pattern to design my application. So a quick reminder what Model-View-ViewModel is. Model-View-ViewModel is a pattern with separation of concerns. It has 3 layers. I have the model where I should have all my application, the business logic, the data models, the services, and so on. Then I have another layer, which is called the view model, and the view model's purpose is to prepare the data for the view. So the view model will use the model and read the data, and it will prepare the data for the view. And the view will only have to use data binding to connect the UI elements to my properties in the view model. And the really good news is that in this pattern, the model and view model should be UI agnostic. So shouldn't have any reference on the UI framework. And this tells us that the model and view model could be included in a pure .NET library, and only the view is dependent on the UI framework. And of course, the Model-View-ViewModel pattern is not enough to build a full application. You will also need the commands to execute actions from the UI. You will need a navigation service and a dialect service to move from one page to another or to interact with the user. You will need a modern application dependency injection, so you can easily inject your dependency in the needed classes, and you could use messaging, publishing, and subscribe. And the rest of my session will be actually to look at some code. So what I have done here, I have taken an old Xamarin.Forms template. So this template was the template that Visual Studio 2019 used for creating a new Xamarin.Forms project using Upshell. And why I chose this template is because you see here I have views and view models. So it makes me understand that I have a basic implementation of Model-View-ViewModel. So for who doesn't know how Xamarin.Forms works, I have all the shared code in a .NET standard library. So here I have the UI and the logic, and then I have 2 heads, one iOS and then one Android, that creates the native application and runs the shared project. And just to look at this application, I will bring the Android emulator and I will run the Xamarin.Forms application. So it's pretty easy, pretty simple. I have a tab page with 2 pages and one about page that it will open when I click a link. It will open a web page, and then I have another page which is an items page, where I have a list of items where I can go and see the details of the item, and I could add new items. So let's get back to this code. So we said that the 3 layers are the models, the view models, and the view. So right here in the application, I have the models, which is composed by the item class. So I have the items and the services. So I have an interface that simulates data store, where I can add, delete, update items and get all the items, and an implementation of this interface using in-memory objects. Okay, so this is my model. The models and the services, the folders are my model. Then I will go to the views. So I have my pages. I have the about page, the item details page, items page, login page, and new item. Of course, login page is a dormant page, okay, because it's not used. And then for each view, I have a view model. So I have a base class, a base view model that implements a notify property change in order to be able to notify the view when a property changes from code behind. So it implements a notify property change. And then, and you can see here that I have this property, that data store in each view model, that will give me access to the data store implementation. Okay, and then I have all the pages, let's say items view model. I have the items view model, which actually has inside a list of items loaded from the data store, and then I can navigate from one page to another. And what we said in the pattern is that the view model should not be dependent on the UI framework. And right now I can see that here I have reference on Xamarin.Forms, which is the UI framework. And where do they use this UI references? They use it in the implementation of the command and in the navigation. So when I click to add an item, I use the shell object, which is a Xamarin.Forms object. So I take direct dependency on the UI framework, and somehow I violate the pattern. So what I did is to migrate this simple example to MAUI, and you will see Uno Platform, and to take the approach where all my application is inside of a .NET 8 .NET assembly, a pure assembly. So of course we will have to resolve somehow the navigation service, and here I can see I also have some references on the Xamarin Essentials. So I will go right now to Visual Studio Code, and in Visual Studio Code I have loaded the project that you can see on GitHub. And what you can see here is that I have this to-do application, which is a pure .NET library. So pure .NET library, where I have imported the model, the items, the services that I have here. So I have the iData store and the Mob data store. And I've added some more services that we will have a look at them. So right now, let's go where the problems were in my case. So I still have the view model. And right now, if we go to the items view model that took dependency on the app shell, I can see that with the new approach, okay, I don't have any reference on the UI framework. Instead, I am using for the navigation, okay, I am using an interface that I have defined, that it's called the iNavigation service. It's pretty basic. It's a basic navigation service just to understand how it works. And if you want a full implementation cross-platform or more examples, you could have a look at Prism. Prism is a MVVM framework that works on multiple platforms and has an navigation service. So in this navigation service, I can navigate back, forward with parameters, and go back. So I navigate with routes. And of course, this navigation service is dependent on the UI framework. So if I go on the MAUI project, because you can see here that I have created two UI frameworks, one for MAUI and one for Uno Platform. And if I go on the MAUI, of course, I will have the implementation of the navigation service, which is pretty hacky, not very clean. But it's just to understand that I am taking out the dependency of the UI framework and then inject them into my shared project. So here I have the navigation, and actually what I've modified, I've added the login page and added a new service that is IID service that will tell me if the user is logged in and will allow me to log in to simulate the login. So I have a mock, also here I have a mock implementation of the ID service. And you can see that whatever thing I'm throwing at him, I say it's okay, and I can log in the application. So also here in the view models, you could see that I am using the MVVM toolkit. So MVVM toolkit is really helpful because it will actually auto-generate the properties and the comments for me. I don't have to write boilerplate code. So in this case, it will generate a selected item property, public property with get and set, and it will implement the iNotify property change pattern. When I use the relay command, I can see it will generate, in this case, a load items command that will be binded to the user interface. So if I want to look, I can look how of course, the view models and the view are associated, because right now I have the data, I have the view model, and you can see here that in the view model, I inject in the constructor the interface is actually the dependency container will automatically inject me all the services I need. So if I go at the MAUI application, okay, I can see that each page will be connected to its view model. So I look here at the items page, and you can see that in the constructor, I inject the items view model, and it becomes the context for the binding for this page. So whenever I want to add a new item, I will bind to the add item command. And how does the dependency container knows how to resolve these things is because I've registered and told him how to resolve the interfaces, and told him to know how to instantiate the view models and the pages for me. And now that I'm in Visual Studio Code, I could run this project. I will choose to run it on Android. So let's pick an Android. I'll pick the same simulator, and I can start debugging. It's a .NET MAUI application. And what I have is the same application that I did. The difference is that I've implemented the login part. So I have the login page. It will call the IID service, and then if I can log in, I change the main page to I change the main page to the tab bar page from my application. I have the about page, the items page where I can navigate from one detail to another or add a new item. So let's say test item Okay, and this is the description. Okay, so I have the new item. So getting back to the services, you can see I have two services that depend on the UI implementation on the UI platform. I have the navigation service, and then I have what I've called iPlatform service, where is the open browser method that will open me the browser to a certain URI, and this has implementation on each platform. So this is the navigation service, and this is the platform service. So what I will show you right now, so we've seen how the .NET MAUI application works. What I've tried to build, without having a lot of knowledge about Uno Platform, I've built the Uno head. So I will use, for the Uno head, let's use Rider, because I'm on the Mac and I can also use Rider. And what I can see here is that I have the same pure library. It's the same, actually, the same solution is the same project. So what I wanted to have is not to modify my business logic and the view models, and to use the new UI framework. So instead of rewriting everything, I just have to rewrite my UI layer. So I will go to the Uno project, and the Uno project has a shared assembly. I've taken out, it also had WebAssembly, it also had Linux. I've taken out those projects. So I have this to-do app Uno, where I have the implementation of the application in Uno Platform. And what I can see here is that also here I only have the pages, so I only have the UI, and then automatically using the framework, I am associating the binding context to the view model, and I'm using the data binding to connect the UI pieces to the logic. So let's say the items page. You can see here the items page is not a collection view, because in Uno Platform we have the list view, but it's really pretty similar from one to another. So I have the item source that does the binding to my items property that of course is in the items view model. And also here in the application, I can see that I am telling the platform to know how the navigation service and the platform service are implemented, because these are dependent on the UI framework. So I have an implementation, pretty dirty, not the best one of it, of the navigation service on Uno Platform, and the platform service where I'm using the launcher object from Uno to open an URI. So, and also then I have this app CS that puts everything together. What does it mean is that it will know how to inject my interfaces. It will know how to create my application, and then it will know how to navigate, because I'm using some routes. It will navigate from to a view model, and then the view model is associated with a page, and it will navigate to that page. So I could run this application. Let's run it, the Uno platform, let's run it on Android. Okay, I will build and run it. Not that one, it's the mobile one, sorry. And I have the same application that runs on the Uno platform. The UI is a little bit different, but the functionality is there. Missing some functionality because I haven't implemented everything. I haven't implemented the add function yet. So Rider runs the application. We will have to wait to finish the compilation. And what I will see is a similar flow from my previous application where I have the login page. And once I log in, I move to a tab page where I have the two tabs, the About tab and the Items tab. I can navigate to a link, and let's go back, and I can navigate to the details of the item. So all of this is shared code beside the UI. And if I really want, I could also use, let's say, I could also use parallels. So I could use Visual Studio for Windows, inside parallels. Let's see if it adapts. So let's see, I will say run the .NET MAUI head on the iPhone 15 simulator, and it will build and run on my simulator. So I think the most important thing to take out from this session is to think about taking out the dependency of the UI framework from your application. So this way you are independent. You can also reuse the application also with a web frontend. So this is my application, MAUI application, running inside the simulator on Visual Studio for Windows inside the Parallels Mac. Pretty complex. So I have the login page. I can log in, open a new link, the list of items, navigate from one item to another, and add new items. Okay. So I think this is everything I wanted to show you. There are a lot of resources on how to build the UI with MAUI, Uno Platform, Avalonia, and you can choose whatever UI framework you want. Just take into consideration to implement your application and your business logic independent of the UI framework. I think you are on mute.
Thank you so much. Yeah, thank you so much. That was a great session and a lot of options, and we've seen great examples. There was a really great chat in the chat discussion. You can have a look later, but I'm sure so many developers are interested. Thanks for joining.
Thank you. Thank you so much.